for our friends. All right, this is lesson 8.3. I hope that French movie was worth it. So, slope fields. So, a slope field is our lesson today. So, what is a slope field? It's a graphical representation of a set of slopes obtained from a differential equation. Remember that a differential equation involves a derivative, and when I say derivative, you say slope. I'll say that a million times in a row. So that derivative represents the what? Thank you. In lesson 8.1, you learned to solve a diffie-q by separating variables. Even if you can't always separate the variables and integrate, you can still use a diffie-q to plot the slopes for a function. So let's follow the examples, and we're going to be drawing a bunch of slope fields and understand what we're actually drawing at the end. So it says, example 1, find the slopes given by the differential equation dy by dx equals negative x divided by y at the following points. So dy by dx means you're given the derivative, right? That is the same as saying slope equals negative x over y. That means the same thing. In an A, you're given a point. What does that mean? Can you find the slope at that point using that equation? That's what it's asking. Well, do you know what the x value is? Do you know what the y value is? So what's the slope at 3, 2? And the answer is negative 3 over 2. Just plug in x and y. So you're given an equation that represents slope. Here, you notice we need both the x and the y to find the slope. This one, B, it would be, remember that negative and a negative, it's going to be positive 1/3. Yes? Yes. Negative and a negative, but then there's a negative on the bottom. So put it all together. So it's really negative 2 over negative 1. So make it pretty. The whole thing would actually just be negative 2. And then the last one, again a negative, but there'll be a negative on the bottom too. So if I simplify it, it's going to be 1. Next, why can't you find slopes when y equals 0 using that differential equation? That's right. So the slope is undefined. Example 2. It says, find and plot the slopes given by this differential equation, right? Negative x over y, for each remaining marked point in the coordinate plane at the right. So for me to do that, you need to understand what's happening to the right. A slope field is drawing a mini line. And that mini line, you're going to have to estimate the slope with the number given. And what's going to be challenging at first is what really matters is that how you draw the slope 2 and how you draw the slope 3, that one has to be steeper. You know what I mean? And if it's 4, then that has to be steeper than 3 and steeper than 2. And if it's 1/2, it has to be flatter. And when I say the word steeper, it's closer to a vertical line, right? So it has to be in relation to each other. Like, it's going to be impossible to be perfect. But you have to do the slopes in relation to the next slope. And obviously a positive slope is going to go up to the right and a negative slope is going to go down. And the number will tell you how steep to draw that mini line. And when you draw all the mini lines, we're actually going to connect them and make a picture out of it. Fun, right? So, can you see some of the mini lines are already done for you? So what are some points that haven't been done that we can do? Let's do it. So you said negative 1, positive 1, right? So how would I figure out the slope? And I'm going to do it over here. Negative 1, positive 1. What's the slope there?
1.
How did you find that, right? So a negative makes it, right? So there, it's a positive slope, and we're going to do everything we can to make a 45-degree diagonal, right? Up 1 over 1, and make a mini line there. What's another one we could do? How about the one beside it, which is negative 2 and positive 1. What's that one? Using this, right, formula? 2 over 1, right? Because the negative and negative. So this is where it's important. is the one beside it steeper or flatter? So the one here was 1. When I draw this, it better look like it's steeper. What do I mean by that? It better look closer to a vertical line. So I'm going to draw this steeper. See how I did that? Than the one beside it. It's subtle, but you have to be able to do that. How about the one beside it? -3 and 1. What's the slope? And again, guess what I have to do? Make sure, again, it's steeper than the one beside it. In relation, right? One beside the other. You're drawing many lines with these little slopes to them. What happened? Oh, okay. Do you see another point we haven't done? What's this point here? -3 and -1. What's the slope there? So again, negative, negative. It'll end up being +3 over -1. So altogether, actually, will be what? -1. Do you notice the ones beside? This one actually beside it is -1. This is -2. There's going to be patterns, right, that you're going to see. So this one has to be, again, closer to a vertical line than the one beside it. So it's negative, which means it's pointing down to the right, but you're going to be steep, which means it's going to be closer to a vertical line. All right, keep filling it in. Every point that doesn't have a little mini line to it, I need you to put a little mini line with the correct slope. So I'm going to go to -1, -2. Notice -1/2 is going to be flatter, right? Down 1/2. Once you see a pattern, you don't have to keep writing down the numbers. Are you seeing a pattern in each quadrant? Do you see -1, -1 matches +1, +1? Do you see how they match?
Yeah.
So see these empty points. Do you know which they would match up with in the other quadrant across from it? So 1, 2, which one would that match up with? It'd be the same as -1, -2. This one right here, -1, -3 is -1/3, so it's really flat, right? Not quite a horizontal line, but it's flatter. These in quadrant 4 are going to match the ones in quadrant 2. Mm-hmm. I'm listening.
Why is the slope of the one in the bottom left corner -1?
So it's -3 and -1. -3 and -3, and that makes it -1. Thank you. That's going to match this one, 3, 3. Two is going to match -2, -2. Two, -1 is going to match -2, +1. 3, -1 is going to match -3 and +1. So if you see a pattern, then you don't have to keep writing it over and over and over again in terms of doing the rules for the slope. Now, +2, -2 matches -2, +2. So the same mini slope you see at -2, +2. So it's going to be positive 1. Here, 3 and negative 2 matches negative 3 and positive 2. This one up here matches it. And then negative 3, positive 3. Now, what's going to happen at the y-axis, do you think? What's happening here?
You forgot negative 3.
Did I forget a point that I didn't put a little slope in? Right here, right? That matches this one over here? Okay. What's going to happen on the axes? Can we talk about that? So the y-axis, do you know that at every point on the y-axis, the x value is what number? 0. So 0 divided by, I don't care, what's going to be the slope at every point on the y-axis? Which means what kind of line? Horizontal. So everyone along here. The only one I'm going to skip over is that 0, 0. Do you know why? So along the x-axis, what does it mean? That y is 0, right? Well, what happens if you put in y is 0, right? So what's going to happen? So when it's undefined, we're just going to leave it empty. We're not going to put a slope there. Even though you'd be tempted to put a vertical slope down. But I don't want you to. Hey, we did it. Okay, that was your first slope field. That was slow because there's a lot of points. Some slope fields don't have as many points for you to fill in. And then once you see a pattern, you just fill in the pattern that you see. And that takes practice. Example 3. In example 2, you made what is known as a slope field. Congratulations for doing your first slope field. Starting at point 0, 1. Do you know where point 0, 1 is? Starting at that point, it says, follow the flow of the slopes to sketch the solution curve containing that point. What you did with that slope field is you actually have a family of functions that are contained within there. And it matters what point you start with to know what family that you're going to draw. So we're going to start at 0, 1. It's important to know that when you connect the slopes, it tells you what direction the curve is going, that you make sure it's still a function. So if you see, do you see the flow of the slopes? Like as I'm going to the right, the flow says go what direction? Down, right? As I go to the left, what does the flow of the slope says? Go down. It's important not to go, first of all, we have undefined slopes, right? And if we go beyond the flow, you can feel like, oh, I can connect to the flow on the bottom, right? Because it kind of flows together and might even look like a circle. But then it wouldn't be a function. These have to be a function, and it would fail the vertical line test if you go too far and circle so something's on top of each other. Okay? So in this example, if I'm going to follow the flow, I'm actually going to stop on the x-axis, and on the other side, when I follow the flow, I'm going to again do what? Stop on there. What shape does it look like you drew? A semicircle, right? And if I connected the whole thing as a circle, it would no longer be a function. Now it says what? It says follow the flow. We did that, containing 0, 1. It says your graph should be parallel to the slope lines, means you should follow it, and be like an average of slopes wherever it goes between lines. Your solution curve must represent a function whose domain is the largest open interval containing the given point. So you sketch a solution curve. So now sketch a solution passing through the point -1, +1. So do you see -1, +1? Where are we at? We kind of went through that a little, right? So this one I probably went a little too high on. So if I followed the slope, it probably would end up more like underneath here. If I followed the slope from here, it would probably end up a little higher. So it really would look like a semicircle, right? So the first one was a little lower, and the second one probably should be a little bit higher, right? In terms of sketching it. And then have one passing through 0, -3. Let's see if I can do this. See 0, -3 right here? Can you follow the flow? And follow the flow of the slopes as best you can.
So there's no like exact.
Right. There's a bit of a feel to it, right?
Yeah.
Now, what did we just draw on the top and the bottom? We draw semicircles, right? Do you know what that's the derivative for? This? That's the derivative of a circle. And if I could make it a function, it would have two parts to it. So if you solve this diffy q, you would have a positive and a negative for a top part of a circle and a bottom part of a circle. When you're given the derivative and you do the slope field and you connect through a point and draw it, you actually draw what y equals. I'm going to repeat again so you get a sense of what I just said. If you're given a differential equation and you draw a slope field and you pick a point and you follow the flow of the slopes and you look at the picture, that picture just told you what y equals. You're given the derivative and you actually solved the diffy q graphically where you figured out what y equals using a slope field. Many slopes, you pick a point and you connect following the slopes and look at the picture and it tells you what y was, even though you were given the differential equation.
Any point? Or?
You can pick any point. See, if I picked another point, it's just, remember when you do and you integrate, you have the candy? That candy is just a vertical shift. Like, it's the same family, it's just been shifted up or down in terms of that. So these are all semicircles, just where you start at made a shift in terms of that C. Okay, turn the page. We're not done. Oh, guess what you get to do now? You get to actually now solve the diffy q, right? Notice we solved it graphically, right? We saw that it was a semicircle by looking at the graph. Now we're going to do it algebraically. Can you solve that diffy q? Step 1. By what? Yay. Step 2. Separate the So I'm going to multiply both sides by y. Are we here together? Now what do I do? Okay, I'm going to do that up here. Do you know how to integrate y? So it's just basic anti-power rule, right? Add 1 to the exponent and it's 2 and then divide by 2, right? Or 1/2. How about the second one? Add 1 to the exponent and divide by, and again, what do we need at the end? If I multiplied everything by 2, you would get y squared equals negative x squared plus 2c. And if I added x squared to the other side, guess what you should be able to see? 2c is just a constant, right? Are you familiar with the equation of a circle? So x squared plus y squared equals a number is a circle. The square root of 2c is what the radius is. So whatever number you plug in for c will tell you the radius. So if you plug in a bigger radius or a smaller radius, that's the family of circles. And whatever number you plug in for c tells you how big the circle is. Because the square root of 2c is the radius. So if you plugged in whatever to make like 8 for c, that would give you 16. So the square root of 16 is 4, and that would be the radius. If you plugged in a bigger number, you'd have a bigger circle. So can you see back here why some semicircles are smaller and some are bigger? Based on that family. So there's a family of circles of different sizes. If I wanted to get y by itself, do you see that eventually you would have to take the square root of y? And that would create one answer that's positive in front of the square root and one answer that's negative. And when I look back here, the answers that are positive are above the x-axis, and the ones that are negative, right, are below. And if you're given a point, you have to be aware which one to use, right? When the y-coordinate is negative, you'd use the negative. So this one underneath here is negative. You'd have to make sure you use the y equals negative in front of the square root sign. The ones that are above, you'd have to make sure you use the one that is positive. All right. So, right here. What happens when you solve for y? What would happen? So, right here, before I put them together, right? Do you see this y squared equals? You don't have to redefine the variable. But one is going to be negative the square root of negative x squared plus 2c. And the other is going to be positive negative x squared plus 2c. So really you created two functions that together make a circle. This, y equals this, is an equation for a semicircle. This is an equation for a semicircle. Together they make one circle. All right. Do the possible solutions verify your results for example 3? Remember that the solution to a differential equation is a function. That's why for that semicircle. The particular solution for this differential equation, negative x over y that we use, whose graph passes through the point 0, 1. So if I have an equation, how can I actually use that point to not have a c anymore? What would I do? So let's start with 0, 1. Which one would I use? The one in negative or the one positive in front?
The positive.
Okay. Next, what would I plug in for y?
1.
Good. What would I plug in for x? Can you solve for c there? So obviously negative 0 squared says 0, and 0 plus 2c is 2c. How would I get c by itself? You'd square it. And what would it equal? So you can get c is equal to 1/2. Now, when I put it back into the equation, what's going to happen? Remember, it's the square root of negative x squared plus 2c. So if it's 2c, and you want 2 times 1/2, what really is that number if you simplify it? So what, do you see how I got positive 1? Do you see the 2c? So if I plug 1/2 into there, 2 times 1/2 gives me 1. That equation is a what? A semicircle that contains what? That point 0, 1. How about the other one? This one says 0, negative 3. Which one would I use? Okay, let's do that. So it's negative the square root of now what would I do? Why did I use the negative one again? Because the y-coordinate is negative. So 0, negative 3 means the y-coordinate is negative 3. And x again is 0. Could you solve for c? So the negative and the negative, they divide out, and now it's positive. How do I undo a square root? So 3 squared is 9, and then divide, and what does c equal in this case? 9 over 2. When I plug it back in to finish it off, remember I have 2c. So what's 9 over 2 times 2? What's going to happen? The 2's divide out, and you're just going to have 9. What is that an equation of? A semicircle. What point does it contain? 0 and negative 3. See, we solved the differential equation graphically before, right? We saw the picture of the solution. This is the equation of the solution. The graph of the solution, the equation of the solution.
What
where'd the negative go? The negative that was in front of the
Oh, right here. This and this. So think of that as -1 in front. I divided out the negatives. Both sides have a negative. I divided it out. So divide both sides out by -1, and it's +3. And then squared it, and 3 squared was 9. And then I just went from there.
Okay.
And then when I plugged it back in, I simplified the constant and got that. But here, do you get the big idea? The slope field does what? It solves the diffie-q graphically, right? Yay? And then we justified the results by doing it algebraically. Graphically compared to algebraically. Hey, we're not done. Example 5. Hey, what does y prime mean? Slope. Thank you. dy by dx, slope, right? In this case, every point is defined by 1 over y. Does that mean, do I need the x-coordinate to find the slope? No. Okay, it says graph the particular solutions of this. So first of all, draw the slope field. So do you see all those lines? All those points. Do I care about the x-coordinate? Okay, do you know the easiest place to start with is always the axes. So when you're on the x-axis, y is always what? 0. So what happens when it's 1 over 0? Undefined. So the whole x-axis is going to be empty. Got it? What happens on the y? X is what? 0 in terms of that. So if I look at the y, what's the y value right here on the axis? +1. 1 over y just means do the reciprocal. Or what's 1 divided by 1? 1. And guess what? That whole row, guess what y equals every single time in that whole row? Do I need the x? Nope. So every time, what am I going to draw? You guys will be prettier than me. You draw the exact same slope, 1. They better look parallel. What's going to happen when y is 2? That whole row is going to be the same, isn't it? And what's 1 divided by 2? Is that going to look flatter or steeper than the one underneath it? A little flatter, but positive still, right? And make sure, do your best to see that they are parallel by the row. And what's going to happen at 3? The whole row. 1 over 3. It's going to look even flatter. A whole new world just opened up to you today. What's going to happen underneath the x-axis? Now y is what? Negative. How does that affect the slope? It's not going to go up to the right. It's now going to go not up to the right. It's down to the right. And again, once I know 1, it's the whole row that's the same, right? Because the y value doesn't change. The whole row stays the same. So for -1, what is it going to look like? The slope's going to be -1. For -2, what is it going to look like? -1/2, which is going to make it look flatter. The whole row better look parallel as best you can. And then -3, it's going to look even flatter. And however you start drawing it, try to make them all parallel in that whole row. Hey, we just did a slope field. That was your second one. Hey, congratulations for doing your second slope field. Part B says what? It says graph the particular solutions passing through what points? -2 and -1. Let's start there. Can you identify where -2 and -1 is? There it is. What does the flow look like? What's the flow going to the right? Think of it as water, like a river flowing. Bruce Lee. Ever see that famous quote? Bruce Lee, but water flowing? Look it up. So, where is it flowing to the right? Down or up? Right? Can you feel that gentle right here? Like follow the flow going here? What's happening going to the left? And what happens when I get to the axis? I need to stop, right? It's undefined right there. And if I try to continue the flow above it, it no longer becomes a function. Hey, we did better, right? Drawing the second one. Where's Tutu? The ballerina. Tutu? What will the flow look like from Tutu? Up to the right? Can you see the flow? And you see how we have to be careful again, right? What does it look like to you? We just solved it graphically. It looks like a sideways parabola, maybe? All right, let's see what it is. Because now we're going to solve it. We just solved it graphically, right? That's what y equals. Now can I just solve the diffie q? How would I solve this diffie q?
dx by dy.
Close?
dy by dx.
Yes? What's step 1?
Multiply.
Everything by? Let's do it. And then separate the variables. How would I bring the y's together?
Times y.
Good. So one side is y dy and the other side is just dx. What do I do next?
Integrate.
How do I integrate y?
Add 1.
Divide by 2 or 1/2 y squared, right? I don't see anything on the right. How do I just integrate dx? I don't get it. Oh, okay. Now I get it. So the number you don't see there is 1, right? And integrate 1, it's just x. And then don't forget the candy. How would you get y by itself?
Times 2.
And then what would you do? And you have two options. One's going to be positive, and the other one's going to be negative.
Is one always going to be positive and one negative?
Only when you are square rooting to get y by itself at the end, because of that even exponent. Absolute value would also do something like that for you. So not every time, for sure. But because y is squared, that's an indicator that it's not a function. It fails the vertical line test. So that means when I do it, I'm going to have 2, it's going to separate into 2 to make it a function. All right, what's the next one ask? So for -2, -1, which one would I use? All right, and we're going to make our life a little easier. I'm going to redefine 2c1. See this whole constant? I'm just going to redefine it as c. Okay? That will make it easier to solve at the end. So I just redefined 2c1 to just c. So that whole constant now is just a simpler way to solve by c, right? So for -2, -1, the y coordinate's negative, use the negative, and it's going to be -1 equals -2 times -1 plus c. So I plugged in -1 for y, -2, which I didn't do, -2 for x, and now can you solve it? So what happens to these negatives? Divide it out, and now it's +1. 2 times -2 is, okay, keep going. How do I undo the square root? So now it becomes +1 equals -4 plus c, so c equals what?
5.
So let's put it all together, and what's the equation? Y equals negative the square root of 2x plus 5. So now we solve the diffie q algebraically, right, rather than graphically. Can I do it with +2, +2? Now which one do I need to use? The positive one. Can you get c by itself? Square. Oh, I don't need that square root sign after I square it. Square and then subtract 4, and what does c equal?
0.
Put it together.
Y equals square root of 2x plus 8.
No, I don't even need that silly part, do I? Just y equals the square root of 2x. All right. Do you see there's a slope field here on the right? Those are not points. Those are cute little slopes. Which one of these matches that slope field? Here's a test of, like, as soon as you find an error, you cross it out. You ready? The best place to start is on the axes, because that's where you can find errors quick because of the number 0. Makes errors quick. So if the derivative is x, what does that mean? That means just the x coordinate will always give you the slope, right? So do you know when the x is 0, what axis is that? When x is 0. On the which axis? So when x is 0, the slope should be what? 0, which is what type of line? Horizontal. Do you see horizontal lines on the y-axis? A is wrong. How about the derivative's just y? So the y-coordinate gives you the slope. What is true about the x-axis? The y is 0, which should give you a horizontal line, right? On there? Does it? B is wrong. C, can you find a point that gives you the wrong answer for the slope? So, let's say I started here. What point is in the middle? The origin, 0, 0. So that means if x is 0 and y is 0, 0 take away 0 should give me what slope? 0. Does it? Wrong. Now we're down to 2. Which one's right and which one's wrong? Can you find the error in the slope field and cross out the wrong answer? Is it D or is it E? So what do we have to do for D? You take the y-coordinate, square it, and then add 1. So if I start in the middle, if the y value is 0, and I square it, it's 0 plus 1. Does that seem to match? Okay? And as I work up on the x-axis, right, or the y-axis, when y is 1 and you square and add 1, is it steeper, and then steeper, and then steeper? So it feels like D is starting to match. The y value is 0. And if I add negative 2, or add 1 to it, do you see how they match going up? Why is E wrong? Can you give me an example where E would not match a slope on there? So I can go, oh yeah, E didn't match. There's one point it totally doesn't match. So at 1 and 0, right here, if I plugged in 1 for x, I get 1 squared, and 1 plus 1 is 2. Could that be a slope of 2? If I then keep going, do you notice the next one? What number would you plug in for x now? And what's 2 squared? 4, and add 1 more, and it's 5. Is it getting steeper going to the right? It stayed the same. So can you see it fails? And then the answer is D. That's a very popular type of question in AP exam, whether you can interpret a slope field, right? And quickly. So where did I start at? I started on the axes. If I saw any horizontal slopes, I'd also go there, because those are the quickest ways to cross out bad answers. All right, turn the page. The best lesson of all time. Okay, one more time. Last one. You ready? 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 What are you asked to do here? The slope field for a certain differential equation is shown to the right. Which of the following could be a specific solution? That means if you took a point, right? Like let's take 0, 1, right? And you followed the flow of the river. What would the picture look like? What does it look like going to the right? What does it look like going down, right? Do you see that? Which one could and could not be that flow? So I need to look at, no way that picture could match that. Give me a wrong answer. Which one could not match that flow? Give me one example that won't match it. Is that e to the x? No, because that goes up to the right, doesn't it? Keep going. Could it be e to the negative x? The negative means that it's been reflected on the y-axis. So instead of going up to the right, up to the left, this could match b, right? Why could it not match negative e to the x? Where would the picture be then? It would be then flipped on the y, or on the x, I mean, right? It would be flipped down, which is not. What is a logarithm going to look like? What does ln x look like? It looks like this, right? Does it look like that? What does the negative in front do? Reflects on which axes? So the two that you would look at are e to the negative x and negative ln x, right? In terms of the reflection of it. And so the negative on the bottom would reflect up. And what's below would reflect below. You have to know your functions, right? To know which one can match it. And the picture follows e to the negative x compared to negative ln x. Those are the two that you'd have to think most about. But that takes practice. So we have an assignment. Can you see why it's a double lesson? Then we're going to come back to this on Thursday. And so there won't be a quiz on this on Thursday. Aww. So we're going to have to practice together, okay?